Okay, let's do problem 6 of the free body diagram problems. And here is the problem. It says a man has a mass of 85 kilograms, gets on an elevator where there happens to be a bathroom scale on the floor. What does the scale read before the elevator starts moving? And then the elevator starts moving up, and the man notices the scale briefly reads 1,100 newtons. How fast is the man accelerating? And as the elevator is moving up at a constant speed, what should the scale read? And then part D, when he slows to a stop, the rate of deceleration is negative 1.8 meters per second squared. What should be the reading on the scale? So, we got a nice drawing here. Zoom all the way out again. So here's our person on the elevator. Free body diagram, and there's only two forces, the weight and the normal force. Bathroom scales measure normal force. They do not measure weight. But if you stand on the scale and you draw the free body diagram and you sum the forces in the y direction equals ma, well, if you're not accelerating yet, if there's no acceleration, the elevator is not accelerating, it's not moving yet, then you go, okay, normal force minus the weight equals 0. So therefore, the normal force must be equal to your weight. And so mg is 833 newtons. Then you start accelerating up. Same equation, the normal force minus your weight equals ma. But now the scale is greater than, the scale reading, the normal force is greater than your weight, which means there's a net force up. And when you do the arithmetic and solve for the acceleration, you are accelerating up at 3.14 meters per second squared. That's quite an elevator, by the way. The elevator designer would be in trouble because that's faster than most elevators. Well, I guess not too bad. And then for part C, at a constant speed, again, the acceleration is 0. So you're just going to measure your weight. And this is why you feel, as the elevator is going up, but it's stopped accelerating, you feel normal. I mean, you feel the vibration of the elevator, but you don't feel heavier or lighter, do you? And then the elevator slows to a stop. Okay, so now the normal force minus your weight is equal to ma. But now we know what A is, negative 1.8 meters per second squared. So we plug that into, multiply that by the mass, and you get this value. This is your net force. You have a net force of negative 153 newtons. Solve that for the normal force. I think they skipped a step here, but they just add 833 to the 153 to get 680 newtons. You guys agree with that, the other groups? So you're going to feel lighter. That's why you feel lighter. You're not lighter. You're the same weight, but you're decelerating. So you go, oh, and so you should always jump, see if it works. Any questions on the elevator problem? There will be an elevator problem on the test. That is all. Stack your chairs. Go home. Have a great weekend. Bye.